All right, I was hoping for a little bit larger crowd. I'm not sure why they didn't tune in. Probably because everybody's already heard most of my shtick. How many of you here, with a show of hands, have heard about my image model theory for stereo? I know Tom has. Well, maybe I'm in luck then. Anyway, if it's your first time,
By the way,
I'm grateful to the BA. What?
excuse me, Gary, I have to bail myself around threes, but it's not anything against what you're doing. I wanted to mention that. So,
Since there's not that many here, I'll try to get through it more simply and quickly, but I would like to present it. It's being recorded, right?
Okay.
Yeah.
But I'm not going to get any reactions from anybody after they watch a recording. Anyway, I'm grateful to the BAS for allowing me to present, and thanks to Alvin Foster. And I want to say a couple of things before I get going. I'm going to say a few controversial things that you may or may not have heard before, but I want you to hear me out, and then I'd like to make it more interactive, so I would encourage questioning, and you can stop me because I want to try to step you through a certain critical middle section of this thing, and I would like to have some participation.
Go for it.
I'm going to say that stereo theory has less to do with the human hearing mechanism than it does with sound fields in rooms. This is important because the confusion between binaural and stereophonic has stumped loudspeaker development for the last 50 years or so, and I'm trying to figure this stuff out too, and I wish that I could have a little help from the world with it, and so my presentation.
Where do you live, by the way, Gary?
In Lakeland, Florida. Secondly, I would like to say, you tune in and you see all these YouTubers that seem to have the program knocked, right? You move your speakers a few millimeters here, there, and try this and listen, and suddenly everything locks into perfection. I don't claim that. I just want to try to talk in general about engineering sound in rooms. So let's get going. If I can get my screen shared and my program up.
You could do it up there too.
It's a slideshow from beginning is what it is. All right. You got that?
Yep.
Yeah.
All right.
Spatial audio. And boy, do I have a lot to say when you're ready.
All right.
Go ahead.
Good. Can you see this with the picture boxes on the right? This is what I see.
Yep.
Anyway, I want to cut to the chase, show you around a little bit. My room is 21 by 35 feet with a cathedral ceiling running in the long dimension. I've got a second room for the electronics adjacent to this one, and I do all the controlling with infrared relay for my home theater. And this is what it looks like.
Woo!
The screen,
Nice.
I got one of those in my room too.
it's about 16 feet wide and 5.5 feet high.
That's a 235 screen.
3-to-1. 3-to-1. It's supposed to be 3-to-1.
3-to-1.
And this is a Cinerama movie that was changed to, put on disc, obviously. It's not the original 3-screen Cinerama converted, I don't believe, but it's called a Cinerama movie, and it's the widest format you can buy. But it fits on there, so I lucked out. And if you want to include the wife acceptance factor, you get one of these, and the center seat would be the stereo seat, and the other two seats are almost as good because of the way I do my sound.
Yep.
The adjacent room with all the equipment in it which you don't want to see in your home theater.
Is that an Onkyo?
Yeah. I can do editing for audio and video in the electronics room, but I recently discovered, to my great delight, that I can bring my laptop into the actual listening room and edit audio in there and hear the results of my editing immediately and make judgments about the directions of sounds and everything. And it's very interesting because, well, I'll get to the surround sound editing later, which is obviously easier in the actual studio than in the electronics room. These are my speakers. They're called image model projectors for the function that they fill. Namely, you can adjust the radiation pattern with volume pots on top for the front two faces. I want to show you the history of human hearing research for a reason. Number one, to show how much work has gone into psychoacoustics and how we hear directions. And then I want to go into auditory perspective systems, where we put that knowledge to use. And then the speaker positioning gets down to some practical rules about engineering sound in rooms, YouTubers and me, and then virtual reality. I'm not getting too deep into that because I don't understand it that well yet. I haven't got as much experience with it as Alvin and I were hoping that I would have by this time. But the Greeks didn't even understand how you could hear something that was way over there from where you were. They called it the there-here problem. Well, they didn't call it, but our modern researchers called it the there-here problem. How can you hear that instrument when you're standing over here? They didn't know about sound going through the air and stuff. So here's some elements of psychoacoustics that have been done throughout the years. Fechner in 1860, he was there, Blauert. He asked, how can you localize sound when there's no dimensions of space? I don't know what he means by that, but they struggled with questions like these. Strutt and Rayleigh, 1876. The phenomena of binaural audition, Thompson, around 1878. Localization of actual sources of sound, 1934. Experimental psychology, head movements and vestibular something or other in sound localization, Wallach, 1940. Head movements. This guy Wallach set up a bunch of speakers, and he operated signals into each one to see how well we could localize which one was making that sound. This is MLD, I think, 1948. Masking level differences. Jeffress in 1947. All these guys are trying to figure out how in the hell we can hear direction so well. The precedence effect. They started figuring out the sound that comes first is the one that takes precedence in localization. Okay, auditory perspective systems. Obviously, research into psychoacoustics is linked to human hearing mechanism. coding of spatial position, this, that, and the other, pinna, auditory canal, eardrum, HRTF, all this stuff. When it came to stereo, naturally they're going to assume that we need to study human hearing in order to reproduce these sounds if we want to use speakers and stuff. Say, any book you've ever opened on stereo starts out with a human hearing mechanism, right? You got two speakers, two ears. You can hear any sound and anywhere in between those two speakers by means of summing localization. Two speakers, two ears, right? Okay, that's all we need to know. We're done. Put the sound from two microphones into two speakers and send it to your ears, and the ear brain takes care of the rest. Harvey Fletcher and William Snow, stereo and binaural are going to be continually confused with each other. This is Clement Adder's experiment, and obviously it's a binaural experiment. I don't know what he used for microphones, but the receivers were two telephone receivers in the audience's availability. And so you see how they wrote that up. The theatrophone is telephonic transmission where listeners received a separate channel for each ear, enabling stereophonic perception. It was this invention which gave the first stereo transmission of opera performances. It was really binaural, but they didn't know the difference, and they still don't. Alan Blumlein, a brilliant man, came up with the Blumlein microphones, the 45-degree cutter heads for discs, right? A lot of stuff. Two speakers, 60-degree triangle, two ears. We're done. The classic stereo geometry based on equilateral triangle. Bell Labs had a little bit of a different idea. They had the curtain of sound. Does everybody know what that was? Probably we all do. They envisioned auditory perspective systems as a curtain of an infinite number of speakers that could simply relay the sound waves from the stage out to the audience with the same directionality as the original sound that was on the stage, simplifying that down to eventually 3 speakers. But most of the world was 2-channel officially because of limitations in technology and the availability of stuff that you can buy and materials. We were kind of stuck on 2-channel stereo for quite a while, and we were quite happy. So the development of better and better stereo seemed to resolve itself down to a search for greater and greater accuracy. The accuracy of what? Compared to what? Anybody want to venture a guess on that one?
Yeah, my guess when they say accuracy is the most common thought is that it is a true reproduction of the original performance. However, who knows what the original performance was?
Well, my comment gets back to maybe it was live versus recorded, which AR tried a lot back in the early days of stereo and mono.
Okay, but
But that was speaker testing.
in
Well,
particular,
they were transitioning from a live performer to loudspeaker playback in the same space.
okay, but in particular, what element of the reproduction process compared to what other element Is it the microphone signals compared to the output of the speakers?
Can I remind you of the shop talk where AR came on and discussed this with us on shop talk, and the moment of truth was that when you had the string quartet playing versus you had a recording playback on the AR3As or whatever was in the room, nobody could tell the difference. So I asked Mr. AR, whoever it was at the time, so why would people go to a concert? And he said, to hear the hall.
Right, okay.
My suggestion would be there are two possible things that relate to accuracy. One is you bring the performers into your room, and the second would be that you go into the original venue.
Well, all right. That's pretty conceptual, but is there anything in particular in the process between microphone and you that we are comparing to check accuracy? Frequency response?
Everything.
It has to be subjective.
All right.
It has to be subjective.
You got me.
Frequency. All right, I'll give you some of the things that are important to me. Broad frequency response, flat frequency response, dynamic range, relatively low distortion. Most importantly, the effects of my room. And as you can look behind me, I've done an awful lot working on the room. Another thing that is, I don't think, taken into account a lot is stored energy in the system, where energy gets smeared, and what it does is it steps on the smaller signals that follow, which very often are the reflections from the space that the original thing was recorded in, and that tends to collapse the soundstage in terms of depth and width.
Okay, is there anything that we can measure that would tell us whether that is going to be successful or not?
You can measure some things that will tell you if it's going to be really bad. I have not figured out all the things you have to measure and how to measure them for it to be really good. In my case, it's been a lot of experimentation.
Okay. Well, let me just press on. The accuracy of what compared to what? My big idea is this. The most difficult concept in audio is trying to put over what is the object that we are trying to reproduce. Is it microphone signals? No. It's an acoustic event that occurred in front of the microphones. It's not signals for the ears. It's the sound in rooms. I think everybody has agreed with that so far.
Yep.
Okay. So we've been making sound with directional speakers in boxes with all the drivers on the front until something happened.
901.
If you read no other papers on stereo or speakers or anything else, I would recommend this. This is the 1968 paper that Bose wrote to explain all about the reverberant field, the direct field, what it is that we hear when we go to a concert, the whole deal. This is the two papers that were published as one in around 1973 that attempt to explain the development of the 901. And you guys are old enough, along with me, we're all old enough to remember the impact that the 901 had. Some might disagree with that because they didn't end up liking that particular speaker, but it built a factory on a mountaintop, and it was quite a thing when it came out. But my problem was I was an original 901 owner, but I went to England and I started reading all this stuff that those folks wrote about stereo imaging. said, what the hell are they talking about? Stereo imaging, imaging. All right, you can tell where everything is on the stage, right? Okay. Can I hear that? And I had to admit, no, I can't hear it with these speakers. It's very spacious. It sounds pretty good frequency-wise, but I can't pinpoint the soloist.
Did you do that in the auditorium?
No, in my room, in my house in England, where they have hard plaster walls. I had my speakers positioned like the owner's manual recommended, a foot and a half from each wall, the front wall and the side walls. So I was about to go out and listen to some quads or something, and I decided to hesitate for a minute and move my speakers around and see if I position my speakers the way these blokes do their speakers, would that make any difference? So I moved them out a couple of feet and in a couple of feet closer together, and holy mackerel, I fell on the floor. All of a sudden, the center soloist was a tightly focused little ball of sound that sounded like a head floating between the speakers. That's the image in my mind was this person is all of a sudden standing there singing. And I said, holy crap, it's not, the reflected part is not a problem with imaging, it's what causes the imaging. And as you move the speakers around, it moves the reflections around. If I could just figure out what scheme to use in order to make this perfect, I could, but the first thing I had to do was to write to Bose and tell him he's got to change his manual. So eventually, long story short, I got to the factory. I met him, and he wasn't going to buy that he should change his manual to make people put speakers in a certain spot or they wouldn't sound good. And then their chief engineer, Joe Varanth, pulled me aside. He says, you know, if you want to understand reflected sound easier, you don't draw spider webs of reflections. You'll never figure out anything from that. You draw the reflections as mirror images of the speakers on the other side of the walls. Then you can see where the reflections are positioned. I said, wow. I went home and I tried to figure out what would be the best way to draw where speakers should be positioned because of the way their early reflections positioned themselves. So I figured it all out. Go ahead.
I just want to interrupt for a second and say, tell me you were listening to an acoustic event that was recorded.
Yes. Well, it doesn't matter.
Okay.
The center
As opposed
soloist.
to a studio hyper-mixed event. Is that what you mean?
Right,
Yeah.
right.
Yes.
Well, any recording. Anyway, it imaged finally when I put them in the position that I determined by listening was the way to go, which happens to be a quarter of the width of the room in and the same amount out from the front wall. So I wrote this all up and I called it an image model theory for stereo, and I put an assumption in there that all this time we haven't really had a stereo theory to work with. We've all been just free floating on our own. So here's the deal. You got to position your speakers a certain way. You got to have a certain direct to reflected ratio. You've got to you got to know where the reflections are going when you move speakers around, and so on and so forth. And that stereo has been confused with binaural all this time because we have always assumed that we need to mimic the human hearing mechanism, 2 speakers, 2 ears. And that is not the way it works. Well, they read that and they didn't believe a word of it. They said I'm crazy, so I had to, I went home and I published an allegory called The AES Goes to Mars. I'll let you read that there for a second. I wanted to make it 100 years after this, when the AES got a little smarter.
Trinaural, huh? Three-eared Martians. Where's their middle ear?
I'll show you. I got a picture of one.
You ever hear the Chirkindeus?
Huh?
There was a children's story called the Chirkindeus, which was born of an egg that all the different animals sat on, so it came out partly all these different animals, and he only had one ear in the middle of his head. That's all.
That's close. Anyway, imagine this. We find out that there really are Martians out there, and there's Venus people and others. But they don't all have two ears like we do, but they do like music. And they can all go to a concert just fine. Doesn't matter how many ears they have or what their hearing mechanism is. They can all go to a concert and enjoy the same concert. But when it comes to reproduction, the Martians had been using trinaural headphones because that's all they knew how to do. And then they met these Venus guys who had 5 ears, and us with 2 ears, and they said, how can we make recordings and reproduce them for everybody to enjoy? Now, should I ask the group any answers on that one?
2 channels are all you need to start with.
2 channels are all you need, but what about the 3-eared guys?
You can derive a center channel from them.
I think you want to look at it another way. And Gary, I know you're going to go into this, so bear with me if I upstage you just a bit. Because Gary and I have had this discussion many, many times. There are 2 ways to look at sound and the way your brain perceives the sound. There is the quote, normal way, where sound is produced externally from your head. And it is outdoors, in a room, whatever. It's produced externally from your head. Then there's the other way, where the sound is produced inside your ear canal, i.e. using headphones. And those 2 are fundamentally different.
Right.
If you are looking at sound that is created inside your ear, then your brain does not have any advantage of your individual head-related transfer function. And now you would have a problem with the Martians and the Venusians and the humans. However, if, as Gary is talking about, creating a sound field external to the air, then that sound field, whether a Martian walks in or a human walks in, they will perceive it with what they are used to since the day they were born, or maybe in the case of Martians hatched, who knows. Their brain has worked with their head-related transfer their whole lifetime, and therefore the sound field will be perceived through their individual head-related transfer. So if you can create the sound field, it should work for everybody. If you're talking about having headphones, that the headphones are in the auditory canal, then you have to have some way to reference everybody's individual HRTF. And some people are going in that direction, but that's not what we're talking about here. So I look at it as if the sound is created external to your head, then it is a field, and now what do you want to do to create a sound field? Regardless of what kind of sound field you want, what are you going to do to create the sound field? That's
Tom Homan's answer is the first thing you do is you create front wide channels.
Well, all I'm trying to get across is that there is a difference between creating the sound in the ear canal versus creating it in a space. And now I'll let Gary go into his method of how he creates a sound field.
Let me continue with the development of this thought, because it's important to understand how to create an auditory perspective system in a room versus a binaural system. You might have a three-eared Martian. They might even have an ambisonic hearing system where they hear in ambisonic A or ambisonic B or even 5.1 format or whatever. It doesn't matter what their hearing mechanism is. If they enjoy a live concert, they can enjoy a field type reproduction system. We got to go back to what I said was there are two ways to reproduce a sensory experience. That is in your vision system or in your auditory system. Sensory experience, okay? Direct sensory input, like headphones, or you can reproduce the object itself and just let all the beings sit down and listen. For example, if you're talking about vision, you want to show these guys what Queen Elizabeth looks like. You can either take a 3D picture, but for the Martians, with their three eyes, it would have to have three lenses and be reproducible to him with three imagers, right? So that doesn't work. That's a direct sensory input where your hearing or vision mechanism matters. But in a field type system, if you reproduce the object itself as a wax sculpture of Queen Elizabeth, then everybody, every little character that wanders into your planet can go up to her and look her over. They can see what size and shape she is, what colors her skin and clothes were. And that is the object itself. For audio, we're talking headphones as a direct sensory input has to be created with a dummy head, right? That mimics the sensors of your head. The object itself is loudspeakers in rooms. And that's what we need to realize in order to do it right. You got a head-related system, binaural, versus a field-type system, stereophonic or surround. And I lump stereophonic and surround in the same type with field-type systems. If you can create the sound in the room, you've got the problem licked. It also involves acoustics, of course, because making the sound in another room requires the acoustics to support what you're trying to reconstruct in there.
By the way, physics has gone through the same transition. There are no longer objects and forces in physics. There are just fields.
Oh, yeah?
So it really is a kind of evolution away from particularization and into something more general. So, for example, things like entanglement and all that stuff and wave particle duality is subsumed under field theory. So it's really nice that you're doing that.
Well, you're beyond me there. What do I got next? Stereophonic and surround sound are field-type systems which have nothing to do with the human, Martian, or any being's hearing system. Okay, this is the controversial part. But in order, what I'd like to advance everyone to is to study sound fields in rooms. You need to study direct reflected ratios. You need to study the spectral and temporal and spatial characteristics of sound fields in rooms. Spatially, we need to talk about the direct, the early reflected, and the reverberant fields. For some reason, Bose only talked about the direct and reverberant fields. He left out the early reflected fields. I don't know why, and he wouldn't answer that, but he just, in a concert hall, you don't have much of an early reflected field. You just have the reverberant field all around, right? That may be why.
But the early reflections are incredibly important.
That's right.
The reason why he did not want to address it is early reflections can cause problems, other problems in the sound field. It can cause congestion. Your brain does not deal nicely with early reflections as it does with intermediate reflections, which are ambience, and late reflections, which are echoes.
Right. And in a concert hall, sometimes you got a 5 or 6 second reverberation time, right? But as long as it reverberates and falls off smoothly, it sounds really good. So we talk about spectral, which is frequency response, temporal, which is reverberation time, and spatial, which is, can you see this drawing?
Yes.
Okay.
What is spatial?
Spatial is the directions from which sound images come. You remember Siegfried Linkwitz's drawing here?
Mm-hmm.
It shows the reflections as a mirror image on the other side. Now, let's get down.
I don't know what mirror image means, well, really.
Hmm?
I don't know what mirror image means in this case.
If you can see this whole drawing, mine is blocked off by the boxes of our faces, but the sound reflects just from the nearby walls, just like light reflects from a mirror.
Okay.
I'll show
Except
you.
that the speakers are facing forward and the reflections are behind it.
Yeah, that's a problem with direct firing speakers, isn't it?
Yeah.
Okay, let's get down to basics on speaker positioning and engineering sound in rooms. What I have observed in all of the videos that I've seen of these guys trying to tell you how to do stereo is that they are completely unaware of the spatial nature of sound. When they move their speakers around, they talk about frequency response effects, and they do talk about imaging because everybody wants good imaging and can hear it when you get it, but they don't relate it to the early reflected sound in their rooms at all, as if they're not aware of it.
Can I interrupt for 1 second, please?
Sure.
Yeah, I just want to make one point. When you talk about reflected sound and you talk about reflected light, you have to take into account, if you're dealing with light, is the light collimated or is the light diffuse? And you've got the same situation with sound. Is the sound very sharply defined or is it diffuse?
Okay, I'll get to that in a minute. So for the YouTubers, I would offer a more organized engineering way of moving speakers around and designing speakers and relating the image model of the sound in your room to the image model of a typical live sound field. The broad categories of things that matter are radiation pattern, speaker positioning, and the acoustics of the room itself, the reflecting surfaces in the room. Like I said, if you try to imagine speaker positioning and stuff with the vector diagram technique, you go nuts. I like the image model, which shows the images of these 2 speakers create reflected images of 6 more speakers behind the walls around them. Now you can see the positions of everything.
But your speaker is away from the wall, is that right? So you must have subwoofers in the system? Because your front pair are away from the wall.
I like the SAT sub system because it gives you more the flexibility of the radiation pattern in the satellites, but the subwoofers doesn't. The directionality doesn't matter that much. So my correct position is a quarter of the room width in from the side walls and out from the front wall. What that creates is a network of speakers and reflected images that are perfectly evenly spaced from each other. If you deviate from that, you can tell with a diagram of this type what happens to your sound. If you've ever wondered what causes a hole in the middle, here you go. Too close to the corners. Also, as Richard has alluded to, if you have speakers that are sunk into the walls or shoved into the corners like a Klipschorn or something, it can't have these extra images around it, can it? So maybe
Correct.
that's something to think about. Maybe if we take a look at the image model of live sound, this is a typical live sound. You can imagine the reflections of the instruments as additional sources on the other side of the wall. This is a technique in architectural acoustics that they use to design concert spaces, I guess. I mean, they could use it. It's not exactly a mirror image, but you want to get the spatial nature of the sound on the stage to have some spaciousness like this, right? If you compare that...
When you have multiple images, don't you get interference between them?
Only if you
Yes.
don't do the room right. For example, this is superimposing the image model of your speakers onto an image model of a typical live sound field. The spatial nature of the reproduction is the same as the live model. Now you see what I mean by spatial nature. The result is, if you had only box speakers, the imaging tends to be like this. If you have more omnidirectional speakers, it tends to image in a plane behind the actual speakers and from wall to wall in the front wall. And that is because of these extra sources, especially if they have more output to the rear than to the front. Sound familiar? Dipoles are a particularly interesting case.
I was going to ask you about them.
If you take a pair of good dipoles and position them as I suggest, and angle them in 30 degrees, the rear of them will also be angled out 30 degrees, and the corner secondary reflection will be at its strongest with that angle coming back to you, and it will happen to be, that will be the deepest and the widest part of your total sound stage, which if you turned this in any different way, you'd screw it up. Like a lot of people take their dipoles and they put them straight on, right? So the reflection is just straight behind it, and it just comes straight back out, and it misses the listeners, and it doesn't help with spaciousness or depth or anything else. These speakers sound particularly good, as a lot of audiophiles have said, and that's why. What else? This is the general case. I call these the corner secondaries. They're the most important reflections. They're caused by a 30-degree angle between that face of the speaker and the wall. Brings the sound back to you in the strongest possible wave. Whereas the front face is also at 30 degrees inward, aimed more toward the listener on the right side of your sofa, and the same for this one, aimed at the listener on the left side of the sofa for a sort of a cross-firing effect for time intensity trading. keeps the center image stabilized, the greatest possible depth of imaging, and time intensity trading, and evenness of all of the real and virtual images is the grand plan that I see for speaker positioning, radiation pattern. We'll get to acoustics in a minute. So what that led me to was a speaker that is something like mine, only it has faces that are angled at 30 degrees instead of 45 degrees. It's got volume controls on all four faces to enable you to shape the radiation pattern to your room. You might want less direct sound, you might want more, you might want this, that, or the other. You might want actual volume pots on the speakers, or you might want electronic controls at the listening spot. And that's what such a speaker might look like. I made
It's gorgeous. It's gorgeous.
I made a styrofoam model of the speaker that I would like somebody to make for me, but I don't know how to make speakers, so I just made a model of a speaker. And it's reversible. If you turn it around, it's got gold fascia, and the drivers are all the same, so you can adjust the imaging to your room. What else? Acoustics.
And they're dipoles or bipoles?
They're multi-directional speakers. They are image model projectors.
But they're in phase.
They have one set of input terminals, do they not?
Yes, they could have.
And if I apply a battery to them, do the cones all move out? Do they all move in, or do the front ones move out and the back ones move in, or?
If you had a single input, like the right channel, into that speaker, and you had volume pots on all four faces, that would be adequate. You could also have different inputs to all four faces and control the radiation pattern electronically, couldn't you?
I'm just trying to understand what your model is.
Because a dipole, the rear output is out of phase from the front output.
No.
And so that changes whatever you're going to get reflections,
Well,
I assume.
Mine is a bipole.
Right. But my KLH 9s were dipoles, and I outgrew them very quickly and sold them to Dr. Land of the camera, who bought them from me at a nice price.
Oh, yeah?
In 1980 or something.
All right, if you had a speaker like this, and if you reversed the connection on the rear drivers, they'd become a dipole, wouldn't they?
Yeah.
All right.
I'd like to give you a little personal experience, because I've had many different kinds of dipoles. I've had Janssen electrostats, I've had Heil AMT1s, I've had Bollinger Graebner RD75s. And I can tell you, in a room that I had in Chicago, where I was able to get the dipoles significantly away from the front wall, they sounded good.
Yeah.
What happened originally with Linkwitz, he said that you need about 5 meters from the front wall. Then he built the Orions, and he realized that nobody was going to buy the Orions because they couldn't move them 5 meters from their front wall. So he
15 feet?
Yeah. And he generally backed off, and in his later discussion says, well, with the Orion, you could be 4 feet from the front wall. Here again, the problem of a dipole configuration, or any configuration, is if you get early reflections, it tends to mess up the sounds. With the dipole, when you pull it way far away from the front wall, you don't get early reflections from the front wall. And the dipoles will cancel at the sides, so they eliminate problems with early reflections from the front walls. And if you have a line array like the RD75, where it is basically a cylindrical wave launch, you don't have early reflections from the ceiling and the floor. Once you start getting early reflections, with a typical dipole placed too close to a front wall, you run into problems.
Right.
And that's personal experience.
It's just boring. They're boring when they're up against the wall.
Early reflections tend to cause congestion, and you lose the detail and the texture of the sound.
And let me tell you what I found when I had I made a box speaker that had speakers on all the faces for a certain reason. Anyway, in this model, I found that if you don't diminish or almost get rid of this particular reflection, as you walk from side to side, the whole soundstage collapses to that side.
Right.
That's why it's correct to try to diminish the first sidewall reflection. Then this is the most important reflection, and obviously the more output to the rear of each speaker, the more it lights up these reflections and causes a harmless image shift toward the reflecting surfaces, which is what makes the sound image in this plane rather than speaker to speaker. And it makes it deeper and it makes it wider. So you learn a lot by doing a multi-directional speaker and studying the model. People that are making direct firing box speakers, don't seem to know anything about this. And so nobody is helping to develop this concept, which is how to reconstruct a stereo image at home from a concert recording.
But you're still using the head model if you're talking about two basic speakers. The two basic front channel speakers from which you're hoping to get everything.
It's confusing, isn't it?
It's depressing because in the room that I'm in, I have a 13.2 surround system from my Marantz receiver, and I've added another 8 channels of surround from my Lexicon D1. And I've learned it just in the last DC one, and I've learned in the last just month that my whole experience in this room depends on playing the Lexicon 6 extra channels loud enough.
Yeah.
There's a moment, all of a sudden, I don't want to go to bed because I'm in another space. I am really somewhere, but it has to come from behind you.
Yeah, I have learned. Well, I have proposed in the last video or presentation that I made to Smootums that surround sound become the new paradigm for auditory perspective systems, because stereo is just not enough.
Stereo just means solid, and that doesn't mean, it doesn't give you the other dimension.
It's too easy to confuse stereo with binaural because it's two speakers and you got two ears. Right. And so people think that's how it works. But if you want to place sounds in rooms rather than in ears, you go to surround sound, and those people seem to understand it a lot better. So all speaker systems.
Yeah, go ahead.
All speaker systems should be surround sound, where you can place images anywhere that you need to in the mix. And you know what it sounds like live, so you know what it should sound like on playback, and you can't do that with just stereo. You need to study more about putting sounds in rooms, not in ears.
The current Linkwitz speakers really do that. With two speakers in a room in the right position, they really recreate the original sound field.
Is there a sweet spot, or can you move around?
You can move around some, but there is a sweeter spot.
Yeah, I wish I could hear them. I have heard so much about them from Absolute Sound. Tom Martin reviewed them, right? And I haven't been able to hear them.
I'm going to Axpona. They're going to be there. I know them. I'm trying really hard not to buy a set.
How much are they?
About 20 grand.
No.
I can
Yes.
tell you.
Yes, they're 20 grand, but that includes all the amplification, electronic crossover.
Oh man. Okay.
I can tell you that if you have just two speakers in a room that is not causing a lot of early reflections, and you have good time alignment of the drivers, and you can produce a very realistic sound stage, but it will not go past the speakers. If it's going past the speakers, you're getting room effects. And room effects, if they are early reflections, now Gary is very lucky, he's got a huge room, so he doesn't run into early reflections. My room is 20 feet long by 16 feet wide, and I can tell you that if you don't do something with room treatments, you will get early reflections off the ceiling and the walls, and it will cause problems with the detail and the resolution of the image. If you do it properly with two speakers, you can get a huge sense of front to back depth. You can place images on the stage, not to a tenth of a millimeter, it's not going to happen, but you can place images on the stage, but it will not do what Gary's system is doing. It will not get the sound beyond the lines between your ears and the speakers.
Right.
Okay, let's get into acoustics, and I want to draw you a picture of the kind of sound that I'm getting here, if you'll bear with me. Acoustics, like Tom says, this matters a lot. He had his room done by Grimani, and that seemed to help whatever needs he had in his room. We both have a friend named Ron Bauman who runs InSound Omega Micro, and he happens to have a cabin where he has put his system that has amazing imaging. Everybody that goes there says, wow, I've never heard imaging sound like this anywhere. And his walls look like this. He put up all these half logs all around, and his wife helped to decorate this artistic, you might call it, diffusion everywhere. My theory is that if you want to diminish or remove the signature of the sound that tells you the size and shape of your listening room, it's diffusion that does that. And I conclude that from this sort of thing. And if that's not enough, this is George Massenberg's Blackbird studio in Nashville.
Woo! What a shame he doesn't like music.
It's nothing but pegs. It's not absorption. It has to be pure diffusion, right? That's the way I see it.
But he's got lots of speakers around, which is my technique. In the room that I'm in, there are speakers on the ceiling and all over the place, and they're all unified together.
Yep.
So that I can take them in and out and have most of the sound field generated by the surround system.
Yep.
And I can, if you have a minute, can I give you a guided tour? Because I want to make sure you see this room before we part.
All right. Let me finish up.
Yeah.
I might go into VR here.
Yep.
I'm using a Zoom.
Wow.
A Zoom H3 VR recorder. It does ambisonics, first order ambisonics.
How many channels does it record in?
4.
4, okay.
Here's the interesting part of that. They have a program that converts it from ambisonic A to ambisonic B, and from B it can convert it to anything from mono to 5.1. Including, they claim, binaural, but I don't know if I believe that. But here's the thing. you bring the laptop into your listening room, and then you put the 6 channels of the 5.1 on your laptop, and you have to be able to figure out which drivers can make the program map the channels correctly. There's MME, there's ASIO, and there is Wasapi. Is that familiar to anybody out there? Do you record? Anyway, you take these channels, which are left, right, center, LFE, left surround, and right surround, and you steer them anywhere you wish in your listening room. The directions are obvious for left channel, center, and right channel, and left rear and right rear, and you can actually do object-based panning instead of just channel-based, and you can make the sound come out anywhere from right at the speaker to over here in each channel, and you can just shape the sound field the way you want. And I've recorded a couple of symphonies like that, and I can tell what I'm doing now that I'm in my listening room doing all this stuff. But on playback, you also need to know which mode of your receiver to use. When I do my mic check and I stand on the right side and then on the back and then on the left side and then up front of my microphones, then when I play it back, I expect to get those same directions on playback. It only happens when I'm in the correct mode, which is called multi-channel. It doesn't work in DTS Neural X. It doesn't work in Dolby Surround. None of the other surround modes work except plain direct multi-channel. For whatever reason, I don't care. I just need to know what mode to put it in to play it back on, and now I know, because I'm right here in the listening room. And when I play my sound, an ordinary stereo recording images something like this, from wall to wall in the front, right? That's what Tom was talking about. Most stereo comes out just speaker to speaker, and he can't get it to go much beyond that. I can with my reflected sound going around. But when I use 5.1 surround sound, it sounds like this. It actually can image the frontal sound stage beyond the corners of the wall, of the front of the room. Quite accurately, as a matter of fact. You can do a runaround with clappers and voice.
You're doing 5.1, but from two channels, or are you doing the 4.0 channel thing?
Actually, if you record in MS stereo, you can get this effect as well. Because MS stereo is almost ambisonic B format surround sound. I can get the audience applause over here and over here to the sides. I can get the good placement of all the instruments up front, and even some sounds can come from the rear with just 2 channels recorded in MS stereo. Everyone know what that is?
Microsoft.
No. It's mid-side.
Mid-side. Mid-side. Mid-front.
Yeah, one mic points straight ahead in a cardioid configuration, and the other mic is a bidirectional figure of 8, which records the left side straight away and the right side in inverse phase. In mixing, you can make them come out to left and right. So you can encode the sound anywhere from over here to around to the other side and almost to the rear. But with the H3 recorder, it's even easier and more precise as far as directionality. We haven't talked much about binaural itself, which is a whole nother subject. As for the sound path between the sound source and the auditory But between the sound event and the auditory event, there's a lot of elements in the sound path, like pinnae and the ear canal and the eardrum, and of course the dummy head that records it. Somewhere in there we need to figure out precisely how to record and reproduce 3D audio, so that I'm thinking with a head tracker is part of the solution. I don't know, but if I ever have to go to a assisted living and lose all of this stuff,
Right.
I'm going to want to have something like this. If this can do the trick, because you can see 3D video in there, you can hear binaural audio. Is that the solution before we get to heaven or not? I don't know. But I thank you for your attention.
Thank you for a very interesting talk.
Gary, before we get too far, I just want to mention to the folks, Gary was kind enough to send me a recording he did of the Harrison School. And even on the stereo that I have, it is amazing. There is such depth, such detail. You can tell where the audience is. Everything up to the point, obviously, where you can't go past the speakers, but anything front to back, his recording is great, and I use it as a test all the time.
Can you send it around?
Yeah, I might be able to.
I would love to hear what it sounds like in my room, which has 23 channels.
Okay, how do I get this thing back, Ken? I want to get back to the Zoom meeting.